Good morning, students. Today we are going to study further in this third chapter about electric potential. Today our focus of study is an electric dipole. What is an electric dipole? Look at this diagram. Here we have a negative charge at point A, that is minus Q, and a positive charge at point B, that is plus Q. It is separated from each other at a distance L on the right hand side and distance L on the left hand side. So the total distance from A to B is 2L. So the two charges are separated by a distance of 2L. Therefore, if we define a dipole, an electric dipole is a pair of equal and opposite point charges placed at a small distance of 2L. Then its dipole moment is known as electric dipole moment. It is a vector P having a magnitude equal to the product of a charge and the distance between the two charges and a direction pointing from the negative to the positive charge. So an electric dipole is basically this arrangement of a negative charge and a positive charge separated by a small distance which we consider as 2L. Then there is a dipole moment, electric dipole moment denoted by this vector P. Vector P describes the electric dipole moment caused by the two charges separated by a distance of 2L. It also gives the direction of the electric dipole moment. Now to find the electric potential due to this dipole. If this arrangement is kept somewhere, then what is the electric potential of this dipole? There are three possibilities, three cases. We have to find out the electric dipole moment and its related electric potential. First case will be if we consider a point P on the axis, that same line joining with a point P far away from it, such that the distance from the midpoint to that point P is given by the letter small r. In that case, there are three possibilities. One is the point is on the axis in this way, or the point is on the equatorial line. That means if I make a line over here and if the point is lying somewhere around in here, point P, that's the second case. And then third case is when the point is at any arbitrary position. Third case. So now we start with the first case, that is potential at a point on the axis of a dipole. Let AB, this is what we are going to find out, potential at a point on the axis of a dipole. Let AB, which we have already seen, let AB be a electric dipole formed by the two charges minus Q and plus Q, coulomb, placed at a small distance 2L meter apart in vacuum or in air. Let P be a point along the dipole axis at a distance r meter from the midpoint O of the dipole. Here we have to determine the electric potential at the point P. the distance of P from the charge plus Q then will be R minus L. Once again we'll consider that the distance of point P, if we consider distance of point P, this is point P and this is O, the distance of point P from this charge and from this charge, minus Q charge. So point P and minus Q charge is total R plus L. This is R plus L is from minus charge, and from the positive charge the distance is R minus L. Since it is coming here, this much of distance is R minus L. So from the positive charge the distance of P is R minus L, and from the negative charge is R plus L. That is what is written over here. The distance of P from the positive charge plus Q is R minus L, and that from the negative charge is R plus L. Therefore, the potential at P due to the charge plus Q of the dipole can be written as V1 is equal to 1 upon 4 pi epsilon naught Q upon R minus L, and due to the charge minus Q, it is written as V2 is equal to minus Q upon 4 pi epsilon naught R plus L. How did minus come over here? Minus is the charge of that small point charge. It is negative. Since it is negative, I have written that minus over here. So these are the two potentials at point P. One is due to the positive charge, the other one is due to the negative charge. Therefore, the total potential will be an algebraic sum of V1 and V2. So V is equal to V1 plus V2, which can be written as V is equal to Q upon 4 pi epsilon naught 1 upon R minus L minus 1 upon R plus L. Then if I take the LCM, we get Q into 2L upon 4 pi epsilon naught R square minus L square. But on the numerator it becomes 2QL. 2QL is actually the dipole moment. 2 into L is 2L, the length of the dipole, and Q is the charge. So 2Q into L is the electric dipole moment, which can be given by the letter P. So here I can substitute it as P, so it will become V is equal to 1 upon 4 pi epsilon naught P upon R square minus L square. So 2QL is equal to P, therefore V is equal to 1 upon 4 pi epsilon naught P upon R square minus L square, where P is called the electric dipole moment. If R is very large, R is greater than 2L, in that case we can write V is equal to 1 upon 4 pi epsilon naught P upon R square in volts. So this becomes our electric potential. This becomes our electric potential due to a dipole moment P, due to the electric dipole. Now we are going to see the second case. For the second case, we have to see the potential at a point on the equatorial line. For that, we'll see the diagram. The diagram is in this way. We have at point A, we have positioned a negative charge. At point B, we have positioned a positive charge. And at the midpoint, that is called the midpoint, is there is a line joining the point P. This point P and the origin O if we put it together by a dashed line, that line will be called equatorial line. So this point P is lying on the equatorial line. The distance from P to O is R. The distance from A to O is L. From O to B is L. Therefore, the total distance between the two charges is 2L. This is a setup, this is a dipole such that a point P is lying on the equatorial line. So this is our second case. We consider a point P on the equatorial line. Now suppose that the point P is situated on the equatorial line of the dipole AB at a distance r meter from its midpoint O. The potential at point P due to the positive charge therefore can be written as V1 is equal to 1 upon 4 pi epsilon naught Q upon R. But R is actually the distance from the point. Here the distance from point P to minus Q to positive plus Q, from P to positive plus Q is actually some distance. Let's say BP is the distance, B to P. That BP we can find out if we consider this triangle POB by right angle by the hypotenuse theorem.